Hello, my dear children. This is P. Venkateshwarlu, PGT Physics. Okay, see here the continuation of system of particles and rotation motion. So, in previous days, we have already discussed about torque and couple. Okay, you understand, children, that torque and couple. Now, we are going to discuss about angular momentum. So, what is that? Angular momentum. Yes, angular momentum. Angular momentum. L. Angular momentum, it is denoted L. Okay, understand, it is a vector quantity. It is defined as the product of momentum and radius. Okay, the angular momentum, it is defined as the product of perpendicular distance and momentum. It is denoted L. So L is called vector. Okay, so it is denoted the product of L bar is equal to R bar cross B bar. L bar is equal to R bar cross B bar. Or we know that P is equal to MV. Rearrange this, L is equal to R into M into V bar cross R bar. Or L bar is equal to M into R bar cross V bar. Okay, understand? The product of mass, radius and velocity of the particle, we can say angular momentum. Okay, it is a vector product, it obeys cross product. So we can write L is equal to MVR sin theta n cap. MVR sin theta n cap. So see here how we can derive this formula. Okay, so consider one axis and consider one rod. Radius of the rod is R. Okay, so in this case, so we have to consider the rod at the end. We can have mass. Okay, so the mass revolves around particular axis. Say it is y, like this. In this case, velocity is acting. Okay, like this. Velocity tangential. Okay, so the component of velocity along horizontal and vertical. So we can write V cos theta and V sin theta. V cos theta and V sin theta. The projection of velocity vector along horizontal V cos theta. The projection of velocity along vertical V sin theta. Okay, so like that. The particle moving in a circular path. Understand? See here, like torque tau is equal to S perpendicular distance into a force, like that. Here L is equal to perpendicular distance into momentum. Okay. Momentum M into V sin theta. Understand? M into V sin theta medicine. Okay, understand? R into rearrange this MVR sin theta. L is equal to MVR sin theta. Understand, medicine? V sin theta. Okay, so we know that radius vector and mass into velocity sin theta. This is about angular momentum, my dear children. So what is that angular momentum? The product of momentum and perpendicular distance is called angular momentum. It is vector quantity. Okay, so where we can observe angular momentum means in revolving electron in a nuclei. So in particular orbit. So according to Bohr's second postulate, So we know that the angular momentum of the revolved electron around the nucleus, which is equal to nh by 2 pi. Okay, so that angular momentum conserved based on that. So based on this topic only, so in chemistry we can have one rule, okay, one postulate, that is Bohr's. Okay, so next coming to my children, relation between torque and angular momentum. Relation between torque and angular momentum. So like relation between momentum and force. Relation between angular momentum and torque. Relation between angular momentum and torque magnitude. Okay, so L is angular momentum, and tau is moment of force or torque. Okay, see here we know that angular momentum L bar is equal to R bar plus P bar, or L bar is equal to M into R bar plus V bar. Okay, this is the formula. So differentiating both sides. With respect to time. Okay, d by dt of L bar is equal to M into mass is constant, d by dt of R bar cross V bar, d by dt of R bar cross V bar. Okay, understand? So we can apply division rule, not product rule. Okay, so we can use that formula d by dt of uv. Okay, understand? D by dt of uv. So we can apply that formula v into du by dt plus u into dv by dt, like that. U into dv by dt, my children. Okay, understand? Now m is common, v into v bar plus dr by dt plus v is common here. Next R bar cross dv by dt. Okay, rearrange this m into v bar cross dr by dt, position by time, velocity, plus R bar plus a bar dv by dt a. Okay, the clue is here dr by dt is equal to v, dv by dt is equal to a. Okay, understand that, children? Yes. dl by dt is equal to m into v bar cross v bar. Understand? According to cross product, v bar cross v bar, same is there, v into sin theta, v into v sin theta. Okay, the angle between both velocity vectors is 0. Understand? 0 plus r cross a. Rearrange this r bar cross ma bar, r bar cross f bar. Okay, perpendicular distance into force. Okay, rearrange this, my dear children. We can get torque, perpendicular distance into force. dl by dt is equal to r bar cross f bar tau bar. Tau bar. Understand, my dear children? The rate of change of angular momentum is directly proportional to applied torque. Okay, my dear children? So now this is the relation between angular momentum and torque. We know that torque perpendicular distance and force. Angular momentum perpendicular distance and momentum. Okay, so we know that L is equal to mvr. So differentiating both sides, we can get dl by dt is equal to m into d by dt of r bar cross v bar. Okay, so we can apply UV rule, differentiation form like this. d by dt of uv means v du by dt plus u dv by dt. Okay, one is constant into another variable, we can change. So by using this formula, we can modify like this: v bar cross dr by dt plus v bar r bar dot dv by dt. Okay, dr by dt v, dv by dt a. We can substitute here v bar plus v bar 0. Okay, so according to vector product, we have to write according to vector product I cross I 0, j cross j 0, like that. Okay, so then r bar cross a bar, mass is there. Rearrange this r into m a bar. M a means according to Newton's second law. According to Newton's second law, that is F is equal to ma. Okay, so by using this according to torque formula, we have to write dl bar by dt is equal to tau. Okay, so like the rate of change of momentum is directly proportional to applied force, like that, which is analogous to like that. Okay, my dear children, next torque and angular momentum for a system of particles. Torque and angular momentum of system of particles. Torque and angular momentum of system of particle medicine. Okay, see here, we know that the definition of torque, force into perpendicular distance. We know that definition of angular momentum, L is equal to mvr, the product of perpendicular distance and momentum. Okay, see here, for system of particles. So system of particles means consider a body. Okay, the body made up of number of particles. Okay, each particle or each minute particle having some momentum, some velocity, like that. Okay, so consider group of particles or group of objects in which each having different angular momentum and different torque. Okay, so angular momentum L for system of particles. Okay, the total angular momentum says the vector sum of all angular momentum of all particles. Okay, like that we can have n number of particles, like that L1, L2, L3 and so on plus Ln. Okay, understand? So this we have to write this L1 and L2, sigma I is equal to 1 to n Li. Understand, my dear children? Understand or not? Okay, so then we know that like that torque. So tau tau for system of particles. System of particles. The total torque is equal to the sum of all torques due to different particles. Tau 1, tau 2, tau 3 and so on, tau n. So this is equal to sigma I is equal to 1 to n tau I. Understand? So simple, we have to find the total, the sum of all angular momentum of all objects. Okay, my children. Next, so we know that the total torque. So tau bar is equal to d by dt of sigma I is equal to 1 to n Li. Okay, understand my children? Tau is equal to summation I is equal to 1 to n d by dt of Li. Okay, understand? So the rate of change of the sum of the angular momentum is equal to net torque. Understand? Net torque. Okay, this is about torque and angular momentum of a system of particles. Okay, so here once again angular momentum of different particles means group of particles or system of particles. The total angular momentum is the sum of the individual bodies of angular momentum like this. The total summation we have to take like that. Torque for system of particles, individual torques we can add. Okay, by from both equations we have to get like that. So this equation tell us the net torque or the total torque is equal to, so the rate of change of angular momentum of system of particles. Understand, my children? Coming to next one, conservation of angular momentum. Okay, conservation of angular momentum, my children. Conservation of angular momentum. Conservation of angular momentum. Okay, see here like that conservation of linear momentum. So when we can said to be conservation of linear momentum, it means when net force acting on the particle, the momentum conserved. Means initial momentum is equal to final momentum. Here in this case, angular conservation of angular momentum means the net torque acting on the body is 0. So when net torque is equal to 0, okay, L is equal to constant. Understand, my children? When net torque is acting on the system of particles is 0, then momentum, angular momentum will be conserved. Okay, angular momentum will be conserved. So according to previous condition, what is tau is equal to d by dt of L. Okay, understand? L, if tau is equal to 0 means tau net is equal to 0, then d by dt of L is equal to 0. Okay, L is equal to 0. L is equal to 0 means in this case Li minus Lf, initial and final 0. Understand? Means Li is equal to Lf. Means angular momentum of initial is equal to angular momentum final. Angular momentum final, my children. Understand? So when net torque acting on the body is 0, the angular momentum will conserve. The angular momentum will conserve. Examples. Example, first one, a circus acrobat. Okay, acrobat, my children. Okay, see here. So a circus acrobat performs beats involving spin by bringing her arms and legs close to her body or vice versa. And bringing the arms and legs means arms and leg means close to each other means angular velocity increases, radius decreases. Angular velocity increases, radius decreases, then moment of inertia also decreases. And second example, a diver. Okay, so while swimming, you know very well about diver. Say a diver performs somersault by jumping from high diving boat, keeping his legs and arms and stretched first and later curling his body. Okay, his legs and arms are stretched first, then curling his body. So in this case, angular velocity increases and radius decreases. The moment of inertia also decreases. Understand? See, my children, this is the example. So you know very well. So while observing.